Okay, topic for this video is going to be composite transformations. We are going to be looking at how are more than one transformation used to determine an image. All right, so we've been looking at a bunch of transformations in these past videos. We know that transformations can be used to make changes to any geometric shape. These transformations can take pre-images to create similar or congruent images. And a composite transformation is the result of more than one transformation. All right, so a composite transformation is when two or more transformations are combined to form a new transformation. So for example, if we've got our X and Y axis here, and maybe we're going to take a triangle over here. We're going to slide it up here. So that'd be a translation, right? And then, actually, you know what? Let's get a little color in here. So maybe we slide it up there. And then what we do is we take that thing and we just blow it up. We dilate it. Right, so that would be a translation followed by a dilation. Now, in case we wanted to track some points here, so if this was point A, then this is going to be A prime. And this one, if we do more than one transformation, we tack on even more prime notation, so that'd be A double prime. Okay, so this can get a little wacky at times, but let's take it one step at a time and see what we can do here on example one. So example one's got some points here. Let's get those down. A's at 1, 1. B's at 2, 5. C's at 4, negative 2. Let's see where those are. 1, 1, 2, 5, 4, negative 2. Okay, so this is our triangle. And we're going to reflect it over the y-axis followed by a rotation of 90 degrees. So first, to get things started with that reflection over the y-axis. In a previous video, we talked about reflections. The rule for the y-axis was negative x, y. So let's start with that. If we change those signs, we're going to get negative 1, 1. We're going to get negative 2, 5. And we're going to get negative 4, negative 2. So negative 1, 1, negative 2, 5, and negative 4, negative 2. So that's the result after the reflection. And now we're going to rotate that thing 90 degrees. So the rotation rule for 90 degrees, in a previous video we looked at these, the rotation rule is negative yx. So A double prime would be negative 1, negative 1. B double prime would be negative 5, negative 2. And C double prime, that's actually going to flip positive 2, negative 4. Remember those negative signs in those rules, they don't mean that it's going to be negative, it just means change the sign. So negative 1, negative 1, negative 5, negative 2, and 2, negative 4. So a little color coordination here. Our original pre-image was this guy. We reflected that across the y-axis to get the first image. And then we used that image as the pre-image for our last transformation that gave us our final image there. Voila. Example 2 says, just describe the transformations that would take triangle ABC to A double prime, B double prime, C double prime. Okay, so where's our original pre-image? So our first pre-image is here, And it looks like we are just sliding it over there, right? We're just doing a translation. And what is that? That is left 1, 2, 3, 4, up 1. So as a rule, that would be x minus 4, y plus 1. And then to go from that one to the final one there, we spun that thing. We rotated it halfway around. So that's a rotation of 180 degrees. And the rule for that was negative x, negative y. So if they wanted words, we gave words. If they wanted the rule, we gave the rule. Okay. Let's go to the inside. So this one says, determine the coordinates of the image after translation left 1 and down 1, followed by dilation with a scale factor of 1/2. Okay, so let's start with triangle ABC. Let's get these points down. 5, 1, 3, 5, 1, negative 3. So 5, 1, 3, 5, 1, negative 3. So here is A, B, C. And first they say a translation left 1, down 1. So left is x minus 1, and down 1 is y minus 1. So let's see what happens after that. A prime, 5 minus 1 is 4, 1 minus 1 is 0. For B prime, 3 minus 1 is 2, 5 minus 1 is 4. And for C prime, 1 minus 1 is 0, negative 3 minus 1 is negative 4. So 4, 0, 2, 4. Oops, that's not 2, 4, that's 2, 3. 2, 4. And 0, negative 4. Okay, so that looks like this. Now that looks kind of goofy to me. Did I mess up somewhere? 5, 1, 3, 5, 1, negative 3, 4, 0, 2. Oh, that's what I did wrong. My B prime was in the wrong spot. My B prime should be here. Okay, let me get this all fixed. That's the original shape. This is the new one. Now we're looking good. Okay, so we slid that thing left 1, down 1. Here's B prime, here's A prime, here's C prime. Okay, now let's dilate that thing with a scale factor of 1/2. Okay, so a scale factor of 1/2, a dilation. Remember, dilation rules are written like this, where we do 1/2 x, 1/2 y. We just multiply the scale factor times the x and the y value. So A double prime, 1/2 times 4 is 2, 1/2 times 0 is 0. For B double prime, 1/2 times 2 is 1, 1/2 times 4 is 2. And for C double prime, 1/2 times 0 is 0, 1/2 times negative 4 is negative 2. So 2, 0, 1, 2, and 0, negative 2. So A double prime, B double prime, C double prime. So let's color code what we just did. So original shape. This one way out there. That's what we started with. That was the pre-image. We took that and we slid it left one, down one to get this guy. And then we took that and we used that as a pre-image for a dilation with a scale factor of 1/2 to shrink it down to that. Looking pretty good there. Okay, what's next? All right, so determine the coordinates after a dilation with a scale factor of 2 followed by a reflection over the line y equals x. Cool. So triangle ABC, A is -2, 1, B is 0, 2, C is 1, -1. Dilation with a scale factor of 2 comes first, but let's get this plotted. -2, 1, 0, 2, 1, -1. Okay, there's our pre-image. Now to dilate the scale factor of 2, we're going to do 2 times x and 2 times y. So A prime, 2 times -2 is -4, 1 times 2 is 2. B prime, 0 times 2 is 0, 2 times 2 is 4. C prime, 1 times 2 is 2, -1 times 2 is -2. So -4, 2, 0, 4, and 2, -2. Alrighty, so A prime, B prime, C prime. And now we're going to take that thing and reflect it over the line y equals x. So to reflect over the line y equals x, that was the rule y comma x, where we swap the x and the y values. So A double prime would be 2, -4. B double prime would be 4, 0. And C double prime would be -2, 2. So just as a reference, one more time, the line y equals x, that's this line, going from the bottom left to the top right, the linear parent function, if you will. So let's see if this reflection looks good. So 2, -4 is down here, 4 zeros over here, and -2, 2 is right here. So A prime, B prime, C prime. And that looks a little chaotic, but it looks pretty good to me. Let's do just a little color coordinating just to make it pop a little bit more. We started off with this pre-image here, and then we blew it up, we dilated it, we enlarged it with a scale factor of 2 to create this one, to create that image. That looks good. And then we took that, we used that as a new pre-image for a reflection over the line y equals x, that red line I graphed, to create this. And that looks pretty good to me. Yeah, that looks great. Okay, so let's take a look at the last bit here. We're just going to be filling out some tables here. So it says complete the table for the following translations, reflections, and rotations. So we're going to start with those 4 points over there, and then we're going to try to remember some rules and execute these transformations. So translation left 2, up 1, that should be x -2, y +1. So let's run through that for all of these. So 1 minus 2 is -1, and 2 plus 1 is 3 for A prime. For B prime, -1 minus 2 is -3, 5 plus 1 is 6. For C prime, 0 minus 2 is -2, -7 plus 1 is -6. And for D prime, Negative 5 minus 2 is negative 7. Negative 1 plus 1 is 0. Now let's take those and reflect those over the x-axis. To reflect over the x-axis, it was x negative y. So for a double prime, negative 1 stays the same. 3 goes to negative 3. For b double prime, negative 3 stays the same. 6 goes to negative 6. For c double prime, negative 2 stays the same. Negative 6 goes to positive 6. And d double prime, negative 7 stays the same. 0 stays the same. And then for the rotation of 270, that is going to be y negative x. So a triple prime, we flip them. So negative 3 in front, and then that negative 1 changes to positive 1. For b triple prime, negative 6 goes up front, negative 3 changes to positive 3 in the back. C triple prime, 6 comes to the front, and negative 2 changes to positive 2 in the back. And D triple prime, 0 comes up front, negative 7 changes to positive 7 in the back. So those would be our final images. And then last one here, same deal, but we got some new rules. So starting off with a rotation of 180, that was negative x, negative y. So a prime, negative 3 goes to positive 3, 8 goes to negative 8. For b prime, negative 6 goes to positive 6, negative 2 goes to positive 2. For c prime, 1 goes to negative 1, 5 goes to negative 5. And for d prime, 4 goes to negative 4, negative 7 goes to positive 7. For a dilation with a scale factor of 2, that's 2x, 2y. So a double prime, multiplying everything by 2, that's going to get to 6, negative 16. For b double prime, we get to 12, 4. For c double prime, we get to negative 2, negative 10. And for d double prime, we get to negative 8, 14. Then we have a reflection over the line y equals negative x. That was negative y, negative x. A triple prime, we're going to flip everything and change all the signs. So negative 16 becomes positive 16 up front, and 6 goes to negative 6 in the back. B triple prime, 4 becomes negative 4 up front, 12 becomes negative 12 in the back. C triple prime, negative 10 becomes positive 10 up front, negative 2 becomes positive 2 in the back. And D triple prime, 14 becomes negative 14 up front, negative 8 goes to positive 8 in the back. All right, it is now officially your turn to try. So check out the problems on that little piece of paper there. Give them a shot and then come back to the video when you are ready to see how you did. All right, let's see here. We got A at negative 2, B at 0, 0, and C at negative 1, negative 5, negative 2, 0, 0, negative 1, negative 5. Here is our starting triangle. And we're going to take that thing and we're going to translate it right 3 up 2. So that's going to be an x plus 3, a y plus 2. So A prime going to be at 1, 0. B prime going to be at 3, 2. And C prime going to be at 2, negative 3. So 1, 0, 3, 2, and 2, negative 3. Looking good so far. Now we're going to reflect it over the line y equals x. That rule is going to be y comma x. We just flip things around. So A double prime is going to be at 0, 1. B double prime going to be at 2, 3. C double prime going to be at negative 3, 2. So 0, 1, 2, 3, -3, 2. Which, if I can draw my lines good, should look pretty good. There's B double prime, there's C double prime. All right. So it should have ended up looking like that. Our last one here, we got ourselves a little table. Translation right 2 down 3, that is an x plus 3, y minus 3. Nope, sorry, that should be an x plus 2, y minus 3. So a prime, -2, -4. B prime is 0, nope, it should be 4, 0. C prime, +2 is 2, and then -3 minus 3 is -6. D prime, -6 plus 2 is -4. 5 minus 3 is 2. Dilation with the scale factor of 1/2 is 1/2 x, 1/2 y. So A double prime is going to be -1, -2. B double prime is going to be 2, 0. C double prime is going to be 1, -3. And D double prime is going to be -2, 1. Rotation of 270 is going to be y, -x. So A triple prime would be -2, +1. B triple prime would be 0, -2. C triple prime would be -3, -1. And D triple prime would be 1, +2. All right, hopefully that went well for y'all, and that's going to wrap this video up.